All right, let's go ahead and begin here. I hope everybody got my email. So the assignment's due at 5 o'clock today, and the reason why I pushed that deadline back is just in case some of what we're doing in today's in-class exercise informs the way that you approach that problem. We've already done the future worth method, and today we're using the future worth method to do a future worth analysis. And it's a pretty fine distinction, but we'll get into that. So after that assignment number 6, which some of you have already turned in, the rest of you today by 5, then of course Wednesday of next week there's both the homework assignment and the exam that's going to be on Wednesday the 20th. I'm going to give you a couple of sample concept questions here in a minute. But for the exam, I wanted to remind you that I'll provide the equation sheet. I'm going to provide the table lookup factors that you might need. And so all you need to bring to that exam is a pencil, eraser, calculator. There won't be any Excel questions on the first exam. Any questions related to the announcements? All right, so today we're doing future worth analysis. And you've already done the future worth method. You've seen the function in Excel where you say equals FV, and you're taking some amounts to a single future year. Well, the difference between the future worth method and future worth analysis is that analysis implies that we're going to make a decision between two alternatives. And so it's simply you're doing the method on two different things, and then you're applying a decision criteria. And remember, decision criteria is simply the rule that you use to decide which alternative is better. So we'll get into that today. But before we do, let's cover some of these concept questions to give you maybe a preview taste of what to expect on the first midterm exam. All right, so who could take a brave stab at explaining what's the purpose of present worth analysis? Okay, that's true. Now remember, just now I was explaining the distinction between present worth analysis and in terms of future worth analysis and future worth method. And so his answer is partly right in that the present worth method you use to find out, the present cost or present value of an individual item. But what about the analysis part of that question? Mm-hmm. That's the present worth method. So that you're on the right track. What I'm saying is that the present worth analysis takes the present worth method and then it makes a decision. And so it's choosing from among two alternatives, two or more alternatives. So you're taking everything to the present for all the alternatives you have, and then the analysis is applying the decision criteria and judging which one should be selected. All right, so I'll say that one more time because it's an important distinction. The difference between the present worth method, which is where we're taking a cash flow that's spread out over many different years, and the method takes it all to one time frame, the present. That's what the method does. But then the analysis says apply the method to many alternatives and then apply a decision criteria, which is it's the rule that you use to figure out which of the alternatives is best. And so maybe our decision criteria is choose the option that has the highest non-negative present worth. And if none of the options have a non-negative present worth, then you'd choose the do-nothing alternative, which is always implied. Okay. What about the assumptions that are built into LCM? By the way, what does LCM even stand for? Least common multiple, right. Now sometimes what students will do in these concept questions is if this was the question, then the answer would be LCM stands for least common multiple. And that's good that you know that. It's good that you understand what the abbreviation stands for, but that's not what the question is asking. The question is asking what assumption is built in. Do you remember what assumption is built in when you apply LCM? Mm-hmm. Okay, good. So it's the repeatability assumption. Just what she said, that the revenues and the costs are repeatable. So if you're going to be repeating some cash flow diagram, then you're assuming that it's possible to do that. Okay, so this is just an example of the types of questions you're going to face in the first part of the exam, concept questions where you have to kind of think and not just plug numbers into equations. Engineers like to do that, but it's important to you that you understand the concept so you know which equation to use and what its limitations are. And so here's another one, MAR. Okay, so in your answer, it's good if you explain what MARR stands for, but that's not the entirety of the question. The question is asking what factors influence MAR. And so we had a part where in the lecture and in the assigned reading material, it discusses that the minimum acceptable rate of return is often a policy choice that an organization sets on what their minimum acceptable rate of return would be. And so do you remember what some of the factors are that determine what you'd set? You know, if your company insists on 8% minimum or 3% minimum, what are some of the factors that govern that? It's going to be a grim Wednesday. Huh?
The highest rate of return on the first project that you choose not to do.
Okay, so he's thinking of the opportunity cost, and so I think the underlying idea is the number and variety of projects that are available. So maybe if you've got lots of options, then you can afford to be picky and insist on a high MAR. And that was one of the factors that we talked about, which is, you know, you may set your MAR just based on the type of business you're in and how many options you've got. That's certainly one of them. The main one that sets the minimum for a lot of companies has to do with how they're getting the money that they're using to finance projects. Do you remember calculating the weighted average cost of capital? And so that's a really big important part of what you set your MAR at. You'd never want your MAR to be lower than the weighted average cost of capital, because then that means you're accepting projects that potentially return less than it took you just to borrow the money to do those projects. And so you'd be doing the project and not making enough to cover the loan. Do you have a question? I know, I was just kidding. Anytime somebody stretches, I try to pin a question on them. So stretch at your own risk. Can you think of another factor that influences the MAR?
Risk associated with the projects that they would undertake.
Very good. Yeah, risk. Excellent. Any other thoughts before we move on? Nominal interest and effective interest. All right, so you know, like the student who isn't really reading carefully would say nominal interest is blank and effective interest is blank. They would just define those two terms. But that's not what the question is asking. The question isn't asking define nominal and define effective. It's asking why is there sometimes a difference between the two. So, you know, read carefully on these concept questions because it's good to be able to define some key terminology, but not all of these questions are asking you simply to define the key terminology. It's also asking something about that concept. So here, what's the difference between nominal and effective? So let me, just so that we get there gradually, if a credit card company gets to choose which one they tell people about, would the credit card company rather tell you about the nominal interest rate or the effective interest rate? Nominal. That's right. The credit card company wants to tell you about the lower of those two because you're going to be in the position of paying that interest rate. And so why is there sometimes a difference between the two? What's the effect that makes it so a 24% nominal interest rate could be actually, on an effective basis, 27%? Compounding. It's the compounding frequency, and you're essentially paying interest on interest, and that's what the effective interest rate takes into account, is how much interest during a one-year period you'd be paying on the interest. So if any of these weren't immediately in your mind the second they came up on the screen, that's an indicator that it would be worth your while to review the notes, to review the textbook, and potentially even go back through some of the lecture recordings that are available online. All right. Now let's revisit the three methods we learned last time to handle cash flow diagrams that have a different length. So the least common multiple approach was one of those methods. And it said that if we have two cash flow opportunities that are of a different length, let's just repeat them until they both terminate in the same year. That's LCM. And we already talked about the repeatability assumption. Contract services says, let's take the short one and make it longer so that it ends at the same time as the longer one. And the way that you're making the short cash flow diagram longer is you find equipment to rent for the intervening years. Yes?
Would it give us the right to keep rid of that, or do we have to?
In what context? Like on an exam or in real life?
Yeah, like on an exam, if you were wanting us to do the contract services approach,
Mm-hmm.
give us how much it costs to rent it, or we have to make that assumption?
You wouldn't have to make that assumption. No, I'd tell you the equipment lease rate. But in the real world, like when you're doing this on the job, you'd start making phone calls. You'd call the equipment company and find out where can you find the stuff for the best price. Or you'd maybe try and lease it on an annual basis. So in the real world, you get that information yourself. But on an exam, I'm not going to have you making phone calls to Ace Rents or whatever. Maybe for the final, but I'll have to think about that. All right, early termination, remember, the problem is one is longer and one is shorter. And we can't compare them unless they're the same length. That's a rule. So our third way of making it so they're the same length is you take the one that's longer and you make it shorter by selling the equipment early rather than using it for its entire useful life. So we learned those three tools when we were doing present worth analysis. You can use those same tools to make cash flow diagrams the same length if you're doing future worth analysis. So far, you see all these orange arrows? They're all at year 0. Well, look at the LCM example. We could have taken all those amounts to year 18 and then compared which is better from the perspective of year 18. That's what we're going to talk about today is future worth analysis. It's exactly like present worth analysis in that the decision criteria is select the one that's higher of the two non-negative options. They have to be of equal time frame in order to compare them in future worth analysis. Now you may wonder, why would someone even bother doing that, taking the amounts to the future? And the most common reason why you'd use future worth analysis is if a project is going to take a long time to construct. Some projects require just a single investment at year 0 to buy the equipment and instantaneously put it into service. But some buildings and some roadway construction projects or land development projects may take multiple years until they're finished and when they start to generate revenue. And so sometimes what happens is an entity will take a construction loan just for the period that it takes to actually build the project, and then maybe if it's been 3 or 4 years, they'll retire that construction loan all at once with selling the project to whoever's going to operate it. And so at that time, you'd want to know in year 4 or year 5, whenever the project is complete and you're now ready to turn it over to the person who's buying the project, you'd want to know how much should we charge them. And so that's a future worth analysis, where you're trying to find out a purchasing price after many years of construction. So this is saying projects where the revenue only begins after several years, such as airports, roads, or when the project is expected to be sold before the end of its life. So those are the two most common implications. The in-class exercise that we're going to practice is, the idea here is opening up a channel for shipping. And that's a project that could not be completed instantaneously. So we're going to use this to get some practice, number 1, applying LCM. Number 2, if you brought Excel with you today, that's going to be very useful, because we're going to solve this using the FV function on Excel. And in the homework, that last problem on the homework assignment, I asked you to do the same thing. So go ahead and start up Excel. I'll give a brief refresh on how to use the FV function. I won't show the entire solution, but I will reiterate what's supposed to go where in the FV function. Thanks. Thank you. Did everybody get their quiz papers? Okay, so let's start up Excel and remind ourselves how the FV function works. Whenever we're doing these money type problems on Excel, it's helpful that we have reserved as our top cell, the interest rate. So it's 7% interest. Year. What's the purpose of the secondary time column that we use when we're doing a future worth method? Yeah, it's because we are taking things to year 9, not to year 0. And so we want to have some column that we can reference for the n value that's going into the function. Okay, so this is another instance where we're going to have a secondary time axis. And then we're going to have 2 options we're going to consider, option A and option B. And for each of them, there's going to be an amount and an FV of the amount. So this is just a suggestion on how you might structure your solution. Okay, these are some possible column headings. You don't have to do it this way. There's nothing perfect about this, but it is one approach. All right, so what you do have to do is apply the FV function correctly. So let me just show that on the first one, where we've got 220 million. All right, I'm going to do all of this to currency right at the beginning, and I'm going to make the pennies not show anymore. All right, so FV equals FV. And it'll start giving us these reminders of what's supposed to go in each field. The first one, rate, should be the interest rate. And so we can just click here on B1, but we want it to anchor there. So it always looks in the same place for the interest rate. So you can either type in the $ before the letter B and before the number 1, or if you press the F4 button on your keyboard, it automatically puts in those $ for you. Okay, so we've anchored the reference to the interest rate, so no matter where we do that function, it's always going to look at 7%. NPER, what's that an abbreviation for? Number of periods, good. Remember, not every period is a year necessarily, so that's why they didn't call it NYERS or whatever. It's not number of years, because maybe we are solving this in months. In this case, the periods are years, but what we're going to use is years until the future that we want this to go to. So that $220 million in year 0, how many years does it need to travel until it's in year 9? It needs to go 9 years. And so we wouldn't want to click here on the first column, column A, because if we use column A, it would be moving it 0 years into the future, and that would be a mistake. Okay, now this is a stumbling block here, this next field. So if I put in the comma, now it highlights PMT. What it's asking is, what's the recurring payment amount? So if I now clicked on this $220 million, you know what Excel would think? Excel would think there's 9 payments of $220 million each. But that's not what we're doing. We're just moving this single amount of $220 million 9 years in the future. So that's supposed to be treated like a single present value. It's not a payment amount. So we need to put in the double comma so that we skip over the payment field. And now who can predict what's the last kind of hint and warning I'm going to give you before I click on that $220 million? The negative sign, because Excel always assumes that it's flipping the sign whenever it uses these financial functions. So minus of the amount. Okay, now before I press enter, let's think logically. If we move $220 million 9 years into the future, as it compounds, is the amount going to be bigger than 220 million or smaller than 220 million? It's going to be bigger. Compounding increases amount into the future, whereas discounting reduces the amounts into the future. So always be thinking like reasonability. Is what Excel doing reasonable? So when I press enter and it says 404 million, yeah, I was expecting it to be more than 220 million. If it had returned something that was like off the charts, huge, like if I'd forgotten that double comma, look what it would say. Instead of the 400 million, now it's saying 2.6 billion. Now, I know compounding is powerful, but it's not that powerful that in the course of 9 years, 220 million goes to 2.6 billion. So that would be an indicator, oh, there's a mistake. I forgot to put in the double comma. All right, so that's just the refresher I wanted to give you on the FD function. So I'm going to stop talking and give you a minute to apply repeatability and decide which of these 2 dredging options is less costly. Which one is going to be the less negative alternative? We have to do one. The do nothing alternative isn't an option in this particular case because the shipping channel has to be kept clear. Okay, they should do option B, right? Everybody made the conclusion that option B is better because it's less expensive of the two alternatives. So I think maybe the stumbling blocks on this are number one, if someone didn't have the secondary time column, then it would be a challenge to have the correct n going into the FV function. We've already talked about the double comma to skip over the payment field. We already talked about the minus sign. But then the other trick is correctly repeating the cash flow diagram. So let's take year 3 as the specific here. So we have to buy the item again in year 3 in order for it to be available to use in year 4. So the cycle is you buy the item in year 0. That means it has to be, well, dredged. We have to do whatever this is, dredging every 3 years. And so we have to dredge in year 0, year 3, and year 6 so that there's continuous uninterrupted service. And so if we go back to the solution here, you can see that we buy it in year 3, year 6, but we don't buy it again in year 9. Because if we dredged again in year 9, then that entitled us to additional years of revenue after that. Okay, so once you've solved the first problem, go ahead and flip the paper over and take a look at question 2. I'll be circulating around to address any remaining questions on number 1. But for now, at least, I'm not going to suggest a separate template for like how to start problem 2. I think that you could use this same approach, like the same column titles for problem 2. But see if you can figure out what's the main idea, what's going on in problem 2. When you're using Excel for a homework problem, it may make the most sense if you put each problem on its own sheet. I mean, I won't insist on it, but that can be one way to help keep things straight. You know, because sometimes the column widths need to be different and that sort of thing. So here I'm going to create a new sheet for the second problem. All right, I've kept you 1 extra minute. I don't like doing that, so I'm going to make sure that I let you out at least 1 minute early when we get together, right? Oh, no. I was thinking my Tuesday, Thursday. We still got 4 more minutes. I'm getting ahead of myself. I don't owe you anything. Quit trying to trick me, you guys. All right, we got 4 more minutes. It's not just enough on problems like this to crunch the numbers and somewhere on the spreadsheet have the answer. Remember, I've already talked to you about the proper annotation of spreadsheets and how it's your responsibility to make your work easy to understand. You know, like that's an engineering skill. Technical communication is an engineering skill. So what we've done here is found the future value of both options, and option A is worth $51,046 if everything's being compounded to the future at 4.5%. So let me tell you what that means. That means that your uncle, if he's just paying this $250,000 out of pocket, you know, this wasn't borrowed money, not only is he making 4.5%, but he's also making an extra $51,000 in future terms over and above the 4.5% profit. So this means even if you did have to borrow the 4.5% in order to finance this opportunity, it would still be profitable. So it's definitely a thumbs up on option A. The problem with option B is that the seller doesn't know how much they want. If the seller wants $250,000, same as option A, then it's a thumbs down for the project because it's not returning as much. Instead of returning $33,000, it's only returning $25,000. So hopefully the seller doesn't want that same $250,000. You know, what if they wanted $100,000? Well, if they want only $100,000, then this is an excellent project. You know, it's returning way more than option A. So the question was kind of like a goal-seek type thing. We're trying to find out how much should they charge in order to make the two options equal. And so that way is data, what-if analysis, goal-seek, and our goal is to set this cell equal to the amount we already know, 51,046, by changing the purchase price, and it will keep playing around with lots of different numbers there. All right, 181,768. Now the interpretation is here. This is, number one, we're summarizing the method we used in order to find the answer. Then a conclusion, you know, just the number by itself isn't adequate. You have to make it really clear. If your uncle pays this much, then the two options are equal. So therefore, if the seller asks less than this amount, then option B is preferred, because then that would give you more profits than option A would. Okay, now I'm letting you out a minute early, but I won't keep you an extra minute on Monday. Hope you have a great weekend. Remember, the assignment's due by 5 o'clock today. Let me know if you have any questions.